as Eric said, I'm going to be talking about thinking asynchronously, but also hopefully you've learned a little bit more about EDA today already, built on your knowledge before coming here. So I'm going to give you a load of patterns. Bear with me, there's a lot of diagrams. As Gregor said earlier this morning, we love a diagram as architects, so I'm going to be showing you loads, but I'm going to try and make it jazzy. I have jokes, I do have dance moves. The world is now going to see them as this is being recorded, so please laugh. It's really important that you laugh, otherwise it's been a waste of my time putting this choreography together. First joke of the day. But who am I? So I'm Rebekah Kulidzan. I'm a solutions architect in our UK and Ireland public sector team. So I look after our kind of government customers in that space. Government are innovative. There are loads of government customers using serverless, so dispelling that myth straight away. Happy to talk to anyone kind of working in regulated space, because I know that can be kind of interesting for some of the stuff we've talked about today. As Eric said, I'm a serverless and event-driven architectures enthusiast. I've done quite a few talks in this space just because I find it really, really fun. I got into tech relatively late in my career. I started off in policy consulting and did a bit of other things on the side, and it's serverless that really got me interested in it. Like, I didn't want to be laying cables, that wasn't my bag. I wanted to kind of dive into the code straight away and figure out ways to build applications that made sense to me. So that's a little bit about why I'm here and what I'm going to chat to you about. But again, kind of diving a bit deeper on some of the stuff you heard earlier, I'm going to go over the common kind of serverless pattern and problem. Why is it that we're telling you to use or try out some of our integration services? Why did Emily, if you went to her talk earlier, say about how and when you should decide to remove code and replace it with something else? And then take you through quite a lot of patterns, and hopefully you can kind of bear with me. So, starting with the common problem. Most applications look something like this. You have an API that might have some security and routing, not routing. You have storage, which has storage. And then compute kind of holds everything else. So these kind of three main components are in all of our apps. But if something's going to go wrong, who can have a guess where it's going to be? Put your hands up. 1, 2, 3. Where's it going to go? Oh, Eric's the only one, and he got it wrong. So if it's going to go wrong, it's going to go wrong here. Why? Well, because it's my code. How many of you have made a problem in your code once and then realized it's definitely your fault why it's not working? Yeah, a few of us. How many of you have cried because you've missed a comma or a colon? Yeah, me, 30 minutes. Call my manager, he read it 2 seconds, found the problem. Horrific, we've all been there. But it's not about human error. As Emily touched on earlier, if you went to her talk with Cinch, writing less code means there's less to maintain, which means it's easier for your teams to run, so it's more reliable. And what we mean by that, it doesn't mean you're going to be writing no code. It doesn't mean that there's going to be no engineers or developers. We still need you. You're really, really important. It just means that you're not going to be wasting time, writing 3 lines of code for an API call or something like that. So, before I dive into some of the architecture patterns, how do you think we could improve this? Well, throw it all in Lambda. That seems to be what most modern applications look like. For those who aren't aware, Lambda are stateless event-driven functions in the cloud. But there aren't that many types of apps with just one function or one entry point, one module. They tend to have databases. I've put an example of DynamoDB here. They have some sort of queue, and then they may interact with a third-party application or an on-premises server or something else. And so this ends up being what most modern applications look like. And you'll also notice that the arrows, which are important, as Gregor mentioned earlier, are also all different colors because they're also interacting with each other in different ways. So not only are the functions quite different and the compute power that you're trying to provide is different, but also those interactions can be quite different too. And if you have something like that, then you might start asking yourself the following. Well, what if I want to sequence tasks or run different tasks in parallel, and then in this part of the application, I might want to retry it, or what do I do with my failed tasks? So, guess where we're going next? Who was listening to the keynote? He's in the room, so make sure that you were. Decouple your application, yeah! That's when you laugh. As you would have heard earlier, and I'm just going to repeat his quote, if you're all listening, you should have been, the appropriate level of coupling depends on the level of control you have over your endpoints. I am not saying this just because he's in the room. Genuinely, one of the best books that I've read in this space. It got me really excited about EDA, and I think often compute books can be a little bit boring. His one is a page turner, all hundreds of them. But in case, just kind of reiterate that in your brain when you're going through. Like, think it's not a one-size-fits-all approach. And so when you're thinking about it, again, it's not a single choice for your full architecture. So as your application grows, many of you work for huge enterprises, you're not going to have a one-size-fits-all to different parts. And so you have things to think about. That might be technology dependency. Are you using kind of Java versus C#? It could be location dependency. It could be semantic dependency. That's another thing that comes up with customers quite often. Or something that I'm going to talk to a little bit more around temporal or location dependency, and that's synchronous versus async. So why am I talking about asynchronously, and what does thinking asynchronously really mean? Well, when speaking to customers, many reference kind of REST APIs or that sort of thing on their radar for communication. But when we think about asynchronous messaging, most of our customers don't really know where we're going or how they can change one part, or they think, oh, but I do need a response back from kind of every part of the application. Now, asynchronous, I'm going to caveat, is not the solution to every problem, and it's about you understanding when to use the right tool for the job and being able to think in that architectural way that Gregor was talking about earlier. But just to recap for those who maybe don't know, to make sure we're all on the same page, the difference between synchronous commands and asynchronous events is kind of how it's displayed here. So for synchronous commands, you have a client that's interacting with service A. Service A then sends a message to service B and needs that response back before it can continue. Now, if you have a problem downstream, say in service B, or as you can imagine, service C, D, E, all the way down to Z, not Z, then you end up blocking your whole application, and it's going to take a long time for that message to return, or maybe it just breaks. How many times have you been on a website wanting to buy a ticket to something or purchase, your favorite shoes before they run out, and it doesn't work, and you go, oh, okay, whatever, I'm just going to leave. That's money lost to your business. That's your application is dropped, all because there was a problem potentially in that messaging chain. Asynchronous events, however, client A sends something to service A. Service A then sends it to service B, but does not expect a response. Why is that? Well, maybe they don't need it. If that's an analytics function, like your business intelligence unit are just trying to get some data, do you need to send something back to your service B to tell service A, oh yeah, we've got that data? Probably not. Taking it out of tech for a second, other thing that's sometimes helpful to contextualize it. Have you ever been asked, how are you? And you just say, fine, good. That's kind of like a synchronous response. If I ask you, how are you doing? And you go, I'm not really sure. Come back to me after I've had my coffee. Asynchronous. You're not ready to respond. You don't need to respond. You've moved on. You don't come back to them, do you? You go and have your coffee and you never respond. There's kind of different kind of advantages and disadvantages to both. So I'm not saying never use synchronous. It can be really, really useful. It's low latency. It's simple. Most developers and architects know how it works, why we need them. And you can fail fast, which actually in development can be really, really useful. But for asynchronous, as I said, it helps with that decreasing that coupling. But also, it's resilient to receiver failure. If service B goes down, that doesn't mean that service A and C and others stop working. And it can also use various different kind of queues and buffering mechanisms that I'll go through in a moment. So if you switch off for the rest of the talk and you don't listen to any of the slides that I have coming, if you don't need a response, and really ask yourself, do I need that response, execute asynchronously. If that's the only thing you take from my talk today, I've done an okay job. So just memorize this slide, get your phones out, take a picture. This one is the most important slide. If you don't need a response, execute asynchronously. Now, a former colleague of ours has a quote that I can't not show. I've took in all of my talks, not just this one. If your application is cloud native, large scale, or distributed, so notice the or, not and doesn't include a messaging component, it's probably a bug. Now, this is a bit tongue-in-cheek, but really, when you start building, and a lot of you in this room, you're interested in the EDA space, you're probably thinking about messaging, if not using it a lot already. But you'll be surprised how many of our customers come to us with these huge monoliths and just go, help. And we've all probably been there before, joining a new engineering team, going in thinking, oh yeah, this is amazing, this is a really cool product, like, love this product, open it up in the back end and go, whoa, I can't believe it's built this way. We've all been there before. And so hopefully some of the patterns that I'm going to show you will help get your juices flowing and thinking about how you can kind of re-architect, build new, and take those ideas back to your teams. So I'm talking about them in the context of microservices, but they're not just kind of microservices or serverless. They can be useful for lots of different types of applications, and I'm happy to kind of take that offline and chat to you afterwards about your different use cases. So the first one I'm going to talk to is message exchange. So how we kind of send messages from one to another. This one's quite simple. You have a sender and receiver sending message A. It immediately kind of shows you that messages are decoupled somewhere, and there's an expectation that there's no response. So how would I know which messages are being sent through? You distinguish that with message intent. So that could be a command message, it could be a document message or transfer, or it could be an event message or notification. In contrast, we have the request response. So the requester sends a message, and the responder works on that message, and then sends message B back to the requester. Two questions you might ask here is how can the responder request a response, but also how can the responder assign an incoming response to the previous request? So you have message A coming through, but how do they know message B is related to message A? Well, again, you have a return address, which is metadata injected into the message, or you might have a correlation ID, which again is kind of a unique ID for that message pinging back, so you know which messages are corresponding to each other, but you don't have to kind of wait for that same message to be pinged back. The first one is what we also call an integration pattern, which you may see used quite a lot. And on the right-hand side is a conversation pattern, or sometimes referred to in literature as a composite pattern. Now, it's probable that most of you are using some sort of kind of message exchange in your applications. The next architecture pattern that I want to go through is the message channel, which again are quite commonly used, but in very different ways. And so I'm going to go over our two most common ones. And the first one is our point-to-point queue. So you could have multiple senders and multiple receivers, but I'm just using kind of one sender in this example for ease of the diagram. Imagine you have many, many messages for your consumer to consume. You add these to a queue, a kind of buffer, while you're waiting for these requests. In this example, it kind of acts like a load balancer for those messages, to use terms we're all familiar with. A fundamental model, which again we talked about quite a lot, is that pub-sub or topic and fan-out model. So publishers send topics to subscribers, and they receive all of the messages that they're subscribed to. So first answer of the day. Imagine when you are waking up in the morning, you're making your coffee, you're listening to your favorite radio station, you're like, yeah, this is the best DJ ever, woohoo, I'm ready for the day, like, woohoo, yeah. Get into my car, still playing it in the tube, like hoping that it stays on. And then you get to work, you've got to turn it off. Hopefully your manager's having a good day. Hopefully your code doesn't break down and you're still in a happy mood. You get back into your car on the way home, get back home, put that radio station on, and again, woohoo, I'm listening to it. In the time that you put the radio on, you were listening to those messages. You were listening to that favorite music. But when you had turned it off, you had nothing. And that's kind of how this works. So whilst you're subscribed to it, whilst it's turned on, that message channel, you're going to receive all of those messages. But as soon as you turn it off, you won't receive anything. And so it won't be kind of queued up in the back unless we combine these two, which I don't have time to go through, but if you want to hear more, my colleague Dirk Freuner does an amazing talk where he dives into this. And guess what it's called? The topic queue change model, wow. They just combined both names and made it really long. So yeah, there are like different variations of this, but I just thought it's kind of cool to kind of touch on some of these that you might have seen before. Now, I do work for AWS, so I'm going to mention 2 of our services that help with this. So AWS offers a number of different messaging services, but the 2 kind of most commonly used that you're probably using yourselves or have tried out. The first is Amazon Simple Queue Service, or SQS. That's our simple, fully managed and flexible messaging service to reliably queue and continuously exchange any volume of messages. Now, when I first did this talk, we had a record set of 47.7 million messages sent per second at peak on 2021 Black Friday. We recently hit that again. It's over 70 million messages per second were processed at peak a couple of months ago this summer with another Amazon sale. So our own organization, Amazon.com, uses these services, and I bet you that you're probably not hitting 70 million messages per second, but if you are, we'll write a blog about it, so please try. So it really, really can handle any load. Whenever customers talk to me about it, like, you know, I just get them to read that and please try and push it, because our service team would love that. And then the second one is Amazon Simple and Notification Service. So that's for that publish-subscribe messaging. It has high throughput and, again, highly reliable. And messages are published to that topic, to that favorite radio station that you're turning on. And with multiple subscribers, it fans out. So that's why you sometimes hear the term fan out. It's because it's got multiple subscribers. There are other services worth mentioning, which some of my colleagues have talked about a bit today. Amazon MQ, if you have specific softwaring needs. And then IoT Core Messaging Broker. For those of you who went to the Serverless Espresso workshop, you will have seen how that was used for messaging. And again, we're happy to kind of take that offline or in the Ask the Experts booth later on. Now, another kind of pattern I'd like to introduce you to is when I first started building this talk, the most common question I got asked about was the dead letter queue. How many of you in the room are using a dead letter queue for your applications right now? Woohoo! Maybe it's because it's an EDA crowd. We've got more hands this time. So it basically allows customers to store messages that the application couldn't consume without breaking down the rest of the application. So an example of that, you imagine a producer is trying to send a message to a consumer, and then message C out of the 3 keeps hitting an exception repeatedly, again and again and again. So we don't want to continue with this, otherwise it's going to cause downstream impacts. So we take that message offline. It could be a sign of a transient failure, or maybe it's a poison pill. Doesn't mean that it's necessarily malicious, but there is some element that you need to inspect there. And this sort of message is basically always going to run into a problem. So the dead letter queue deals with this. It's a separate queue to your main queue channel. And you can instruct it that after X numbers of times of trying, you put a message into that dead letter queue for inspection. What's really important here is that you can analyze the context of these messages outside of your production application. So there's no need for open heart surgery or worrying that you're going to break everything down, or that it could just be that your settings were kind of not quite right for your messages. It doesn't necessarily mean that someone's trying to kind of spam your service. But it's really, really useful pattern. We have this both in SNS and SQS, and the SQS console has a redrive mechanism, which was launched earlier this year, which helps you also redrive messages once they've been inspected in that dead letter queue back into the queue automatically for processing should you want. Again, don't have time to talk into loads of features on this, but happy to chat more after today. The next pattern I'd like to talk to is the asynchronous point-to-point model or router. So event routers need to decide where messages need to go. So in this example, we've got blue messages going to the blue channel and green messages going to the green channel. Seems like a simple logic, just match the messages to the channels that they need to go. But quite quickly, it can become increase in complexity, in logic, and then suddenly you have tighter coupling again when you were trying to make it looser. How can we manage this? With a bus. So imagine I'm here, bus stop A, I've got my blue ticket, and I'm looking for my blue bus to come around. Oh, I don't know where it is. Maybe I can't see it in the dark. Very, very difficult to figure out. Our bus, our event bus, helps us route in the right direction. So we still have a sender and receiver, we still have green and blue channels, but instead of us kind of trying to figure out where everything's going, manually kind of moving it around, our event bus handles that for you. So you imagine you're here with your message, waiting in the bus stop. Oh, that's not my one, that's my one. Oh, that is my bus. Okay, cool, I'm gonna get on. I'm on the bus, oh yeah, great. I haven't prepared a proper dance routine, but here's some choreography. Then I end up over here at my message B, at my service B with my message received. So at AWS, our event bus service is called Event Bridge. So imagine you've got an event bus, not name created by us, but very handy for my dance routine. Event Bridge, that was the bridge that I went on to get there, see? You guys are all gonna do it. I asked people to do this. Nobody has sent me a video on social media, not even Eric. But if you do, like, maybe I can get him to send some credits. No, he doesn't have authority to do that. Maybe try. I want to see your bus dances. But yeah, Amazon Event Bridge is our simple, fully managed, flexible event bus pay-as-you-go service. And so it basically helps with that message routing. It means that you don't have to worry about where the different messages are going and routing it across your application, but it also helps reduce the location coupling. It means that you can focus on the bits of your application that differentiate yourself rather than where your messages are going and which services they're hitting. And it makes life much more efficient for senders and receivers. Now, let's take a look at how EventBridge specifically works. So you start with a number of event sources. And so EventBridge can have a number of different sources, as you can imagine, our AWS services, but also your own custom applications, as well as some SaaS application providers, some people like Salesforce and others that I know many companies use. EventBridge allows you to ingest data from those sources, and you then have a kind of a schema in the center that helps you react to those events. These can include information such as the title, the format, validation rules for each piece of event data. And the schema registry in EventBridge has a load of easy-to-find schemas. So they could be your own. If you've never used it before, I would recommend using some of the schema already in there. So AWS provides some schema that you can kind of tweak and change based on our experience with different customers, as well as our SaaS partners providing schema for their platforms. You can also download this code as bindings for any kind of schema in the registry for your own IDE, which enables you to kind of represent that as strongly typed object in your code. But regardless of the event source or where the event lands, subscribers write rules against these events. So that's the kind of routing element that it takes care of for you. So when I was like jumping on my bus, I wasn't worrying about where the bus was taking me. I just knew that that was the bus that I needed to be on, and it was finding the routes for me. Why? Because it had rules. It knew which streets it was going to go down, which stops it was going to stop at. Sometimes you're waiting on one bus and you see it just go past your stop because it wasn't meant to stop there. That's kind of how it works with EventBridge rules. You set a number of rules that match against the incoming events, so it knows to pick up the data that it needs and where it needs to go in your application. So, and those targets then, the next part could be any number of AWS services, so that we've put like Lambda and SNS here, but it could be EC2 instances, it could be, container services, it could be an API destination into your SaaS applications, and many other kind of targets that you can play around with. Here's a little bit more of how it kind of looks like. So again, you have your event sources from these 3 different places. Your SaaS applications will have their SaaS event bus. A lot of our partners have put together ones for you. You can customize your own as you build out. But I would really, really recommend you starting with the default event bus just to get your head around it, and then you can start kind of playing around. And then there's over 20 AWS services and API destinations that it works with at the moment. And so here's a flavor of the services that it works with, and then we're adding more and more all the time. So if there are services that at the moment you'd love to use with EventBridge and you can't, we've got loads of PMs downstairs and they're going to be on the stage later, so just tell them, because they can get it on there quicker than I can. But please do let us know how you're finding it, try it out. It's a really, really cool service. Now, stop on the sales play. I've talked a lot about events. You've heard a lot about event-driven architecture. So a little bit of a recap. I'm presuming by now you know what an event is. I've got one person with their thumbs up. Where have you been all morning? Eric has no thumbs. So can't believe you said that. So an event is a signal that a system state has changed. So an example, again, taking out of tech, is imagine you turn all the lights off in a room. You can't unturn that light switch off if you need the light back on, but you can produce another event to turn the light on again. So this is essentially the concept that events are immutable. You can't reverse them and take them back. You can't roll them back, but what you can do is create new ones as you're going through. The reason why this is important as a concept is it's also how we talk about them in contrast to directed commands, which many of us are used to writing in code. So in this example, we have a manager saying, Joe, please can you create an invoice? And Joe says, yes, we can. Observable events, however, you'll notice aren't forward-looking. They're saying customer X has ordered a widget. Customer has done something. The first person says, I don't care, it's not relevant to them, they ignore it, moves on. The second person, working in finance, says, oh, I'll send an invoice out to the customer. And then the last person says, sure, I'll add that to the sales report for analysis. So again, here you can see the difference between the two is that one is telling someone to do something, the other is allowing the other people, or in application case, the other services, decide what they want to be subscribed to and what they want to do with that information. But it all starts with business events. And this is, again, some of the talks that we've seen today from Gregor and Emily and others talked about how we pick apart business events. So how do we do this? Well, if anyone can guess what business this is, retail, fulfillment, and support, you've probably all ordered from it at some point. I know I do quite a lot. But imagine we've got a business that has a retail domain, a fulfillment domain, and a support domain. Each of these business areas are going to need information from that one customer interaction. That one customer logging onto a website and buying something impacts all of these business domains, but in very, very different ways. And the reason why this is important to our application development is that you're developing an application that can respond in these business contexts to make sure that the messages, the information from that customer event hits the business domains in the right way, but also the communication back to the customer is sufficient. And so that's where I said it's the right tool for the job. Sometimes you're going to need synchronous messaging, sometimes asynchronous. Sometimes you won't hit one service, sometimes you will, depending on what the customer has done. So we communicate between these events with choreography, with my little dance on the bus stop. This helps create loose coupling between our different communication platforms. And it's an important concept to, again, kind of stick in your head that I've been covering off today and that many of my colleagues have covered. If you went to Marcia's session, she was talking about this in event design, that publishers of events cannot have an expectation of how and if the subscribers will respond. So when you're thinking asynchronously, the big difference and how you develop your microservice is you're pushing that data out and just letting the application do what it's doing. You're not waiting and expecting that response. When there are expectations, which you may need in some instances, you're adding tighter coupling to the model, you're adding extra complexity and potentially some downstream impact should something go wrong. So, In here, we have the publish-subscribe model. My fulfillment center says, notify me when the customer creates an order. Again, the publisher, the retail domain, where we've bought our item, has no awareness of how the fulfillment domain is going to process. But the retail domain doesn't change. Amazon.com still works. Regardless of whether that fulfillment center is replying to them, it just keeps processing our messages. You could have a queue that keeps them if something goes wrong, but that's not of concern to the retail business. That their main aim is making sure that website looks great, that they've got the information on there for us, that the products are up to date, but they don't have control over how the fulfillment center runs its business. Now, I know what you're thinking. Well, I don't want to go on a website, order something, and it's not really there. So how does it work, and how does it not communicate with the other parts of the business? Well, there's going to be some areas where you will need tighter coupling, and that's outside of choreography in something we call orchestration. So within a business domain, you will have a number of steps to check before you push that event out into the next part of your application. So zooming inside the retail domain here, the customer goes in, order up, looking for its item. You then have an inventory manager, again, could be within your application, that checks whether or not something's in stock. If it is, it sends it to the invoice manager who creates the order for the customer, who then pings back, order created, and the first step that the customer comes back with, which is a synchronous response, is here's your order confirmation. It exists, the item exists, at some point we'll fulfill it. That order created signal then gets sent to the fulfillment domain, as we saw in the last slide, but the retail domain doesn't tell it to do anything with it. It just says it's happened. But what the retail domain was able to do was to check if that item was in stock and send something to the customer. We're all following, just about, almost. And how we do this in AWS is with AWS step functions. So again, I'm sure you've seen a lot of it today. If you haven't, it's my absolute favorite service and you should be using it. Please use it. It's our workflow tool. It helps you build workflows, and within that, you have a number of state machines, and each step of that state machine is called a state. Now, there's a lot of jargon in this space, and I'm not going to bore you with all of it. The recordings will be made available afterwards, and I'm happy to chat with you one-on-one. But essentially, what it helps is enable complex orchestration use cases across distributed workers within your application. It allows for resilient workflow automation, so those repetitive tasks that your application is running time and time again, but also for some complex elements, for example, human interactions, where maybe identity checks need to be sent off for a human to review and that sort of thing. It has powerful AWS service integrations, which I'll go through in a moment, and you can also integrate with your own services. It has an auditable history and visual monitoring, and it's all defined in JSON in our Amazon States language. So as I said, it's defined in JSON, Amazon State language, but also you can write in languages of your choice through our cloud development kits and software development kits for data science. When you're creating workflows in step functions, we also have a visualization, so you see exactly kind of how it looks, and why this is really, really important. Our customers are telling us that not only is it useful for the development teams to test things, to try things out, to share with one another how they're working, but actually communicating to business stakeholders why they have built the applications in the way they have, or as many of our colleagues mentioned earlier, why they've restructured the teams in the way that they have. And so you can imagine, in my initial example with the retail business, with the fulfillment business, that it won't just be developers who are interested in why the retail domain has set up the application in the way that it has. You might have a finance manager saying, okay, but when are you checking the amount of stock and the price comparisons? Well, you could show them we're checking it at this point in the customer journey. So it's really, really useful tool and visualization tool to communicate with business stakeholders across your organization who may be a bit further removed from the tech. And then finally, execute and monitor. So quite handily. It goes green if it works, it goes red if it doesn't, it goes amber if it's kind of stuck in the middle. But also you have logging data, which is sent to a database if you're using standard workflows, or to CloudWatch if you're using Express. So there's two kind of integration types. I mentioned it's directly integrated with a number of our services. We have 17 AWS services where it has optimized integrations. And so there are a few patterns that I'm going to take us through to explain a little bit more about the difference between the SDK integrations and the optimized integrations. But the SDK integrations are really, really powerful. You can now call 220 plus AWS services. I actually don't know how many AWS services we have, but I think it's pretty close to 220. So I'm not going to say it touches all, it doesn't, but pretty much most of them. And over 10,000 API actions. So again, we're probably covering most of what you need, but if we're not, let us know. We have some step functions PMs going to be on stage in a moment, so tell him if you don't have something that you need. And then there are three integration patterns. So the first one, request response, is where step functions waits for that HTTP response. And you can do that in both the SDK integration, so across that 220 services, but also with our optimized integrations. Run a job is where you call a service and you have step functions wait for a job to complete. So I'll go through some examples of those in a moment. And then the final one, wait for a callback, is where you have a service, you call a service with a task token, and you have step functions wait until that task token is returned with a payload. It could be success or failure, and that sort of thing. For tasks like these and run a job, step functions can pause indefinitely to wait for an external process or workflow to complete. So again, I mentioned it can be really useful where you may have some human interactions. And if you're using our standard workflows, you can have these running for up to a year. So it can be really, really powerful in cases where you need a bit of a longer time for processes to go through, but you still want that automation. You don't all want it to be human managed. So the first one, request response. So you have a request to an S3 bucket to get some information, some object. You then want to transform something, so you send a synchronous request to Lambda to transform something with that object, maybe make the thumbnail smaller or something like that. And then when it's complete, an asynchronous request pushes it into the rest of the application. So if you remember back to that model again, we have one business domain doing that orchestration piece, and then once the event is done, it's pushed into the rest of the application. And this workflow is independent of the rest of it. EventBridge then takes it and just sends it out to the rest of the application. Again, this is supported across all of the SDK integrations, our 220 services. So whether it's kind of async or synchronous requests depends on which service you're kind of linking up with and which particular API call. Another method is our wait for callback. So here we have a queuing mechanism. So you send a message to the SQS queue, you introduce a task token to that queue, and some context that might be needed for processing that message. A fleet of receivers, in this example I've just put one for ease of the diagram, then tries to process that message, and in case there's a problem, kind of processing. If it's a failure, then it sends a task token failure back and completes with the fail state, and step functions then catches that error and helps you decide how it should be processed. If not, if it's successful, then the receiver sends that success pattern back into the workflow, and then your workflow completes. This is supported in our optimized and SDK integration, so again, with over 220 AWS services. And now the final pattern I'm going to go through today, and I swear this is the last one. Thank you for sticking with me. We're almost at the end. I'm not going to keep you away from drinks any longer, is run a job. So a really common example that our customers are using and where they find this really useful is for big data jobs where you're querying large data sets for analysis. And this can take quite a lot of time. You don't want to be sitting there refreshing stuff yourself. Or it might be a repetitive task. Often data teams run the same sorts of tasks over and over and over again as new data comes through. So here, Step Functions is running a set of event-driven mechanisms to run asynchronous jobs with Amazon Athena, our query service. So it kicks off a request to Amazon Athena and says, can you query the data set for me and get the data that I need? This takes some time because you've got a huge data set, you need to wait for it. And then Step Functions kind of monitors and waits for that response. Then you've got the query response back, so then you can get the results that are needed for processing. You've got your results there, and then you publish that into EventBridge, take those results to the next part of your application. Again, EventBridge asynchronously concludes the Step Functions workflow as before and sends it on to the next part of your application. At the moment, this isn't supported with SDK integrations, but it is supported across our optimized integrations and a number of services here. As you can imagine, it can be really, really useful for IT automation across our code suite of services like Code Build, for data jobs like EMR, Glue, and Athena, for machine learning where things take a lot of time, or batch jobs or containers. So I really, really would advise you trying it out. We also published a blog post on how to use Step Functions with Amazon EKS recently, which is really, really good. So I talked about a lot of serverless stuff in this talk. That's my area of interest and expertise. But Step Functions works really, really well with containers. And so I would implore any of those in the room who are thinking about event-driven, but they still got containers in their application, like you can do both. It's not just a serverless world. Unlike some of my colleagues would like to think. So please do try it out. Step Functions works really, really well across both containers and serverless, and also with traditional EC2. So I've mentioned loads of services today, lots of jargon words, and hopefully you're still with me. But I just wanted to do a bit of a recap before I send you off for a glass of wine. So the first one that I mentioned is Amazon SQS, or Simple Queue Service. That's our messaging service. It's durable and highly scalable. It's fully managed and has comprehensive security. It's also one of our oldest services. And as I said earlier, if you think you can beat 70 million messages per second, please try. We'd love to write that blog post. The second one is Amazon EventBridge. That's for that choreography. If you remember nothing, remember I made a fool out of myself and danced and only like 4 of you laughed. That's our event filtering service. Again, fully managed and scalable, and has integrations with many of our SaaS partners. Amazon SNS, or Simple Notification Service, helps with performance at scale, again, fully managed and enterprise ready, and helps with that publish, subscribed, or fan out approach. And then finally, my favorite service, AWS Step Functions, for workflow automation, orchestration, parallel execution, state management, and much, much more. And I'm happy to hear your questions after this session. So again, recapping, you use orchestration with Step Functions within that business domain, choreography across your application, across those microservices with EventBridge. And if you went to Master's session, you would have seen the slide already, but it's really, really good, so we're showing it to you twice. They are better together. And after this session, you're going to see me again interviewing some of our panelists from both EventBridge and Step Functions and our partners at MongoDB. And hopefully, they will say the same thing here. I think they're better working together, so please try them out. Hopefully, you've had a bit of a flavor and inspiration today. But now, you've heard me talk. I want to see your patterns. Choose them, build, upload them to Serverless Land, ping me on Twitter, and I'm happy to answer any of your questions. Thank you.
All right, thank you.